Here we have a knowledge-based question on polynomial functions, K1, question number 1. It says given y equals to minus 2, x minus 1 times 2x plus 3 whole square. Write the given function in standard form. Without calculating, determine which finite differences are equal. Calculate constant finite differences. Find x and y intercepts and sketch the function. Okay, do your things and then check the answer. So let's start with writing in standard form. Well, that's simple, right? So we say y equals to minus 2 times x minus 1 times 2x plus 3 whole square, right? So we need to expand it. It's better to expand this term first. I've seen students getting confused over it, but I prefer to solve the most complicated one first. Here, when you expand it, a plus b whole square is a square plus 2ab plus b square. So we'll use that, right? So this square is 4x square. At times, people don't square 2, right? They just write 2x square, and that's a big mistake. Plus 2 times ab. So 2 times 2 is 4, 4 times 3 is 12. Plus 9, right? Next step. Now we'll do this and then simplify, right? So with x, 4x cubed, that's the distributive property, plus 12x squared, plus 9x, and minus, let me write here itself, it's easier then, minus 4x squared, minus 12x, and minus 9. Is it okay? Now we can combine the terms. So we get 4x cubed, 12 minus 4 is 8, x squared, 9 minus 12 is minus 3x, minus 9. So that's what we get here. Now we can multiply by 2, right? So minus 8x cubed minus 16x squared, minus and minus becomes plus 6x and plus 18. So that's our equation in standard form. So we got the first part. So that is A, right? Let's do B. Without calculating, determine which finite differences are equal. So what is the degree? Degree is 3, right? So third finite difference is constant, right? Or equal. Now, calculate the constant finite difference. This is tricky. Many students may not have read about it or not have paid attention to it. But there is a rule which says the leading coefficient relates to, if the leading coefficient is an, right, then the finite difference, let's say nth finite difference over n factorial, that is the relation which relates them, right? So we will use this relation. Rather than, what you can do is, you can actually expand. You can put x as 0, 1, 2, 3, 4 and find out finite difference, correct? That will take long time. So we'll avoid it. So finite difference from here we can calculate as finite difference delta, which is 3 in our case. Third finite difference is constant. A times leading coefficient we already calculated, which is minus 8, right? So we get minus 8 times 3 factorial. 3 factorial is 3 times 2 times 1, correct? So that is our finite difference, which is 3 times 2 is 6. 6 times 8 is 48. So minus 48 is our constant finite difference. Okay? Now part D. Find x and y intercepts. Well, To find y-intercept, we have to just plug in 0 here. We get y-intercept, and finding x-intercept is, it is in factored form, right? So it's very easy. So we'll write x-intercepts. X-intercepts are when these factors will be 0 at x equals to plus 1 and at x equals to minus 3 over 2. Perfect. And how about y-intercepts? Y-intercepts will be, you have to equate x as 0. So we get minus 2 times minus 1 times 3 square, right? Because this is 0, so write 3 square. Which is going to give us how much? Minus and minus becomes plus. 3 square is 9. 9 times 2, 18. So y-intercept is 18. Sketch the function. So I have very limited space. I'll just sketch it here, squeeze it in, right? Now, we have zeros at plus 1 and minus 3 over 2. So we'll say our zeros are at plus 1. Let's say this is my plus 1 0. And minus 3 over 2. Minus 3 over, let's say, is 1, and this is 3.5. So let's say this is my 0, right? Now this 0 is of multiplicity 2, and this is linear. Second, behavior. Negative leading coefficient means right side down, right? Degrees 2 and 1, 3, opposite ends. Do you see that? Now you can sketch it. That was our rough work, right? So here, this is 0 of type of order or multiplicity 2. So it bounds, right? So it will have like this, going up like this, something like this, and going like this. So that is our function. It's a good thing to find and label your y-intercepts, right? So y-intercept is 18. So let's write down 18 here. Is it okay? And this is our minus 3 over 2, which is 1.5. And this is at 1. These are our x-intercepts, right? These are our x-intercepts. That's my y-intercept as a cubic function, and therefore third difference is going to be constant, right? That is x, and this is f of x. Okay, that's how we are going to do it. Thank you.